Welcome back, friends, to Cajun Coding. This is St. Raz, and we are continuing on in our exploration of Java. We're in the Array2 series of exercises on the Codingbat website. We're actually a little ways into it, and we're picking up where we left off last time. The exercise, name of more14. The instruction's pretty simple. Given an array of ints, return true if the number of ones is greater than the number of fours. And that should be pretty easy. Let's go ahead and make some variables for each of those values. And then do a for loop and this is very similar to some previous problems. This is about repetition, and sometimes why they're called exercises. Got to do a lot of reps to become completely familiar with the use of some of these conventions and tools that we have at our disposal there. And it should be pretty easy. If and we're going to just use the plus plus incrementer. And it says given an array of ints, return true if the number of ones is greater than the number of fours. And we don't have to use an if, we can just return one count greater than 4 count. That should do it. And next exercise, phys array. Given a number n, create and return a new int array of length n containing the numbers 0, 1, 2, and so on to n minus 1. The given n may be 0, in which case just return a length 0 array. Now they do say you do not need a separate if statement for the length 0 case. The for loop should naturally execute 0 times in that case, so it just works. I don't know that it needed to tell us that, but let me see. In an array of length n, let me see. So int answer equals new int, and then we're going to put the number, the size of the array there. And let me see, and we'll put answer I equals, it should be I, and then return answer. I think that should do it. Yeah, there we go. Now you'll notice in our edge case here I mentioned 0. They said the for loop would, oh, okay, I understand what they're saying now. In the instance of an array length 0, int I equals 0, I is less than n, since I is 0 is not less than n. So basically the for loop, okay, the for loop executes 0 times, so it doesn't actually run. Okay, when I saw this phrase here, the for loop should naturally execute 0 times, I was thinking they were stating that it would write values into the array, but that's not what they said. They said the for loop executes 0 times, which is exactly correct. So, and let me see, next one would be only 1, 4. Given an array of ints, return true if every element is a 1 or a 4. And true, true, lots of 1s and 4s. This one has a 2, so it returns false. So, and let me see. We don't actually need to count how many 1s or 4s or how many non-1s and 4s we have, so we can just do our pretty standard by now for loop, and we would just return false if we encounter something that's not a 1 or a 4. So if nums I is not equal to 1 and nums I is not equal to 4, then we return false. If we never encounter that situation, we return true by default. Should be it. Yeah, there we go. So in this case, this is one of our cases where, we often run into those where it's easier to test for the false case. We try to find something that makes the assertion false and return that, and then we just default to true. Other times it's more convenient to search for the true case rather, and then default to false if we never find that case that we search for. And next one, Fizz Array2. Did we just do some Fizz? I thought we did some Fizz thing. Fizz Array. Okay, I don't know why they called it that. The FizzBuzz problem doesn't very closely resemble what they just did, so I was kind of wondering about that. But Fizz Array2, given a number n, create and return a new string array of length n containing the string 0, 1, 2, etc. through n minus 1. N may be 0, in which case just return a length 0 array. And note string dot value of xxx will make the string form of most types. The syntax to make a new string array is new string and then inside square brackets desired length. Now this array contains numbers, but it contains strings, so it's actually the characters, not the data type integer, and that's why we call the value of method on the string object to generate those. So let's go ahead and make our array, and this is going to be a string array, and we'll just call it answer, and it equals string. I'm sure there's a reason, I'm not exactly familiar with it, that when we invoke the string, it is capitalized. It's capitalized because it's a string. It's the string object is what it is. But then we don't capitalize it when we do an int. Okay, I need to do some reading. I'm not sure. But string. So our string array is going to be n elements long, and I forgot our new keyword. What does new do? If you've been following along, you should know that. What's new do? New is the keyword that allocates memory in the system. It allocates memory addresses for that array, and when we declare an array like this, it's going to set apart in addresses, indices, each of which contains a memory address appropriate to the size of the data type that we're storing, which in this case is string. So, all right, so moving along. So we've got our array set up of the appropriate type and length. And surprise, surprise, we're going to have a for loop. And we're going to put in string I, and we're going to do the string object, and we're going to call value of, and then we're going to have the parentheses there, and we're going to put in I. And then when we've done all that, we're going to return answer. String 5 string I. Oh, you know what? That's wrong. What is string I? That doesn't make sense. We're assigning answer is what we named our array of strings. But the name of the array is answer, not string. Now, this should be correct. I'm pretty sure this is correct. Yeah, there we go. And there we have it. And I'm thinking I was going to mention something else, and now I've forgotten. What are we doing? Oh, okay, yes. Here, before I ran to the runtime error, we've got, actually it's not a runtime error, it was a compile error. That's why the compiler yelled at me about that. But so we've got answer is the name of our array of strings, and the address is I, which is going to change each time we iterate through the for loop. And we have this string object class, and we're going to call the method value of. Now I is our iterator in this for loop. I is an integer, and what this method does is it makes it into a string. So right in here in our for loop declaration, as we're iterating through the for loop, it's an integer. In here it's an integer. It has to be an integer inside the parentheses there. And then the operation of this method called on the string object turns it into a string when it's written into this address of our answer array, which is an array of strings. Now the address itself is an integer, but the contents of a particular address is the data type we declared for the array, which is in this case a string. So okay, and on to the next one. No 1 4, given an array of ints, return true if it contains no ones or it contains no 4s. Okay, now you have to pay close attention to the wording here. It can contain 1s or 4s, but it can't contain both. If it contains no 1s and it does contain 4s, then that should be true. So it contains 1s but no 4s, that's true. If it contains a 4 but no 1s, that's also true. It contains 1 and 4, therefore it's false. So let me see. And this is one way we can do it. There's multiple ways to solve this problem. The simplest one might be to declare an int 1s and declare an int 4s, and set up our for loop. And just use the plus plus iterator there. This one's going to be pretty much the same thing, except that we're going to be looking for 4. Then once we've done that, we've populated or updated those variables we set, and we return 1s equals 0, which means it has no 1s, or 4s equals get the spacing consistent there. And there we go. Now, let me see. Now, it could be the case, where do we have one? See, 1s or 4s. Okay, see this one? This one has no 1s or 4s. It has no elements, actually. Okay. Now, it could be the case that it has no 1s or 4s, exactly as in here. This is the inclusive OR. So if both of the cases are true, then that inclusive for resolves to true. And just to call back to some of our other problems, we've got the XOR, or exclusive OR, represented by the caret, which means that one part of the statement can be true, or the other part can be true, but if both of them are true, then the statement as a whole is false. And you'll see we have a couple of situations in which that's the case. But in this case, the inclusive OR is fine. And Array2 is everywhere. We'll say the value is everywhere if, we'll say the value is everywhere in an array if for every pair of adjacent elements in the array, at least one of the pair is that value. Return true if the given value is everywhere in the array. So let me see. Let's go ahead and do return true as our defaults, and then inside our for loop we're going to be looking for the exception to that rule, and we'll immediately return false if we find that the value is not everywhere. So and I think, let me see, let's go ahead and take bytes of 2. We'll go ahead and start at 1, and we may run into an edge case where we have an array of just 1 or 0. Actually, yeah, I might have to put just one statement here. If it's less than 2, we'll return false. And they may interpret that differently with that edge case, or we may not have that edge case, may not have to worry about it, but we'll see in a moment. And so if, let me see, if nums I is equal to value and nums I minus 1, actually that's wrong, to value. If nums I is not equal to the value and nums I minus 1, the one right next to it to the left, is not equal to the value, well, then that value is not everywhere. So, and that should be it, I believe. Oh, we found an exception. Oh, look, yeah, looks like for these very small cases, they want to say that the value is, oh, wait a minute, run false. How is that true? So we have a 3. See our value. They didn't tell us what the value was here. So we've got 3. Oh, that's the value. This is our number value. So why is that true? They have a weird case. What if we just don't include this? We'll just comment that out, and it's fine. So sometimes one of the pitfalls of looking for edge cases that don't exist, maybe, and this is also their their interpretation, of how they frame the question. But this works fine without this line here, which could be commented out or deleted. So we're good there. And do note, you see this pattern, in several of the exercises where you're comparing adjacent elements in an array. You look at an element at a particular address and look at the element right behind it or right in front of it. So sometimes you'll be starting your iterator at 1 rather than the normal 0, since arrays are 0 indexed. In that case, sometimes you have to make concessions for looking at the first character or something like that. So, alright, let me see. Either 2, 4. Given an array of ints, return true if the array contains a 2 next to a 2 or a 4 next to a 4, but not both. So, let me see. Actually, we can do a Boolean here. Boolean 2's, and we'll say false, because before we've looked at the array, we haven't found one yet. So Boolean 4's, and we'll make that one false as well. And we'll iterate through the array, and we can start at 1. And let me see, if nums I equals 2 and nums I minus 1 equals 2, then we have found adjacent 2's, and we're going to change that to true. And in similar manner, we're going to do the same thing with 4's. And now when we return it, return true if we find adjacent 2's or 4's but not both. So return 2's exclusive or 4's, like that. And of course, we will have a few cases where if we use the inclusive or, it comes up as false. Okay, let me see. Match up. Given arrays nums1 and nums2 of the same length for every element in nums1, consider the corresponding element in nums2. And by corresponding, they mean at the same index. Return the count of the number of times the two elements differ by 2 or less, but are not equal. So differ by 2 or less. So they're differing by 2 or 1. Let me see. Well, we are counting something. So let's go ahead and set up an integer variable for count. And let me see. Okay, and if they're that close, what we're going to do is increment the count variable, and then we return the count variable. So here's the meat of the problem, right? The conditional inside this if statement there. So see if nums nums1 index I let's defer by 2 or 1. So let's use I'll go ahead and use the math abs function. So nums I minus nums 2I is less than or equal to 2, and nums 1I is not equal to nums 2I. Okay, let's look at this. So if the absolute value of the difference is less than or equal to 2, and the two are not equal, which would mean the absolute value would be 0, which is less than 2, but we don't want to count those. So that should do it. Okay, nums line 3. What did I do? Here we go. Nums. We don't have nums. We've got nums 1 and nums 2. So we'll just pick one arbitrarily since we know they're the same length. And there we go. So, okay, Has77. Given an array of ints, return true if the array contains 2 7s next to each other, or there are 2 7s separated by one element, such as with 717. So if they can see. Okay, so what we're going to do, and it says return true. So what we're going to do is we're going to return false by default, and then we'll immediately return true inside the for loop if we find a condition that satisfies those parameters. And I don't think we need a holder variable for anything. So we'll just get our for set up. So int I equals, and we're actually going to do int I equals 2. I is less than nums length I plus plus. And we have an if here. And the reason we did that, I equals 2, is we're going to start on the third element. If it's equal to 7 and either of these cases is true, the one prior or the one 2 indices prior. So nums I minus 1 or nums I minus 2. Oops, that's not a statement. It's equal to 7, and this one also is equal to 7. So if we have one that's equal, if we have our current address we're looking at, our current index is 7, and the one just prior to it is 7, or the one prior to that is equal to 7, then we return true. And I think I've seen edge case already. Yeah, I'm pretty sure. What if the first 2 are 7s, but the third's not a 7? So you have a non-7, but it's preceded by 2 7s. Well, that's 2 7s next to each other. And yeah, there it is. So we can actually fix that pretty easily. We don't even really need. Let's, for readability's sake, let's put this down here. Okay, and we can extend this out a little more, or that should do it. We don't have any short array. Oh, we do have a short array. What the? Oh, well, it's false. Let me see. Why is that false? Why is it not throwing out of? That is curious. Oh, here it is. This is why it's doing that. Okay. Let's say we get an array with one element in it. Okay. We have one element in the array, but here we look for the element before the only element. Well, or the element before the element before the only element. These are negative negative indices for the array. That should put us out of bounds, right? Well, it does, but we don't get to these statements because the compiler reads this statement. So I equals 2, I is less than num's length. Num's length is 1 or 2. Because of that, it doesn't execute these statements. It skips over the for loop. Now what if we had 2 7s here? If we had 2 7s here, it wouldn't execute. This is accidentally correct. Now if we put num0 and nums1 equals 7, if we put that outside the for loop, it could catch this edge case. But if, can we do it? Custom test? If we have a custom, I don't see an option to make a custom test. My conjecture is if we pass in an array consisting only of 2 7s, this gives us the wrong answer. But you know, if you were to prepare to deal with something like that, you could do it by checking the length of the array. If the array is less than 2, obviously it's going to return false. That's fine. But if the array is exactly 2 and both the elements are 7, then it should return true. It's interesting. Okay, next exercise is Has12. Looks like we're right at 30 minutes. And I think I'll go ahead and wrap this video up. And we'll pick up with Has12 next time. I may or may not decide to go to longer videos later. You know, I'm kind of divided on that. I'm not sure if you're going to have to see more ads or anything, or if it's better just to keep them shorter, keep them about 30 minutes. But we'll see. And in any case, we'll just wrap this up. And if you're eager to get to the next one, then just jump to the next video. I'll have it up shortly. And as always, thanks so much for viewing. Like, subscribe. Any questions, comments, critiques, or requests are always welcome. Thanks again. Talk to you guys next time. Bye-bye.